Now that we have some idea of what symbol tables are, as well as what ordered symbol tables are, let's start talking about their implementation. So implementation. We're going to walk through a couple of these in this video. Well, not in this video, but in the next couple of videos, we'll walk through a couple different approaches. First is going to be using unordered lists. Second is going to be using ordered arrays. And then later on, actually, in the course, right, in our kind of our following modules, we'll talk about these other mechanisms, such as binary search trees and hash tables, in order to implement these. Because it's actually a little bit of a journey for us. We're going to start basically right with some very slow methods, right, implementing this data structure, or implementing this ADT, I should say, and try to work faster. Right? We always want to get better, and we want to get better. We want to get better. So that's what we're going to do. All right. So in general, right, we want to have some sense of how we're going to be analyzing this data structure, right? So we want to find at the end of the day, right, some very efficient way to implement the symbol table concept, right? Symbol table concept or symbol table concept. Probably we're going to have different optimal. We're going to have different optimal answers, right, for both those, because the need, right, to keep things ordered, the need to support those different operations, kind of is it's difficult, right? It's difficult. We're going to be able to do it in a fast way, but if we reduce our requirements, right, if we just say a simple table with no order on it, that's when we'll get kind of the fastest possible implementation. So we'll have kind of trees will be basically our binary search trees will be the fastest implementation of an ordered symbol table, and then of an unordered symbol table, that's where we're going to have hash tables, right? That's going to be the best we can do. All right. So I already mentioned arrays and lists, so I kind of spoiled that second bullet point there, right? But that should be already something that you're thinking about. Whenever you want to go and implement an ADT that contains things, right, something that's basically just a collection, well, it needs to be stored somewhere, right? We need to have some sort of data structure behind the scenes. Data structure for us, right, means that we're going to have something that looks like an array, something that looks like a list, right? We may have something on top of that, right? We could do something like, in terms of like when we talked about priority queues and heaps, right? We had this array with special, logic in there to keep everything in a heap order. Well, for us, right, basically what we're saying is at the low level, we have to have arrays, you have to have lists, right? That should be our starting point, right? If you don't think, arrays and lists, right, whenever we ask to implement a collection of things, then it may be time to visit office hours, okay? This is kind of our very basic tools by now, right? We've been through several courses that introduced basic Java, right? Hopefully your last course did lists in detail, right? We have used them here a little bit for stuff, right? Arrays, right, we've used arrays probably the most, right, because they give us fast performance. But those are our main options, right? Those are the ones we should be thinking about. Now, when we do go to finally implement symbol tables, we need to have some sort of a cost metric to look at. Now, for us, the best cost metric is typically going to be comparisons, right? So basically, it's like, well, if I have a set of elements, I'm trying to do a lookup. How many things do I need to look at before I get to the one that I want to? Ideally, I need only one lookup, right? I need to do one comparison. It's like, bam, got it. I have my one element that I was looking for, right? That's ideal. Not going to really be possible to get there, but that would be ideal, right? And so we're going to use that as kind of our core cost metric. How many comparisons are needed to find something? Alternatively, sometimes we'll use, because it's a little bit more easier to work with, the number of array accesses. So if I'm storing my data in an array, it's like, well, how many times do I need to look inside this array in order to find something? Typically what happens, right, is I do an array lookup and then a comparison. So sometimes just looking at the number of times I look at an array, right, the number of times I access the array, sometimes that's kind of just a little bit faster thing to do. Right? I don't have to think as much. So those will be the operations we look at as we go through several different implementations.